Hello, everybody. Welcome back. This is module 2 of our series around the paper and the data. We're talking, and the software. We're talking about authors and reviewers and editors and the updated journal practices that are out there. And for module 2, we're going to discuss about what the data is we're talking about, which repositories, specifics on availability statements, citations, and give you an example. So with me is Randy Towson. He is our Director of AG Publications and Operations. Hello, Randy. How are you?
I'm well, Shelley. How are you?
I'm really good. I'm glad you're with me today. So let's get started. So when we talk at AGU about introducing these new criteria for data sharing that started in 2019 and had a lot of work that went into it prior to that, there's two questions that were asked that are no-fail questions. What data are you talking about? And the second one is what repository? So in this module, we're going to talk a little bit about that and hopefully clear it up for you. So first of all, data can come in a lot of different formats. And it's these that we're talking about. This module, we'll look at observational data and process data, but there's also software and code and models and images and video and other formats that are important to your research as well. So we do mean all of this data. And to be specific, I want to talk about it in 3 different categories. And they're in the order of importance. So first of all, if you create anything new for your research, and so let's use an example of for instance more recent readings of some sort of let's say oxygen in the ocean in a particular area. And you've generated some additional readings and you're trying to do a longitudinal or time series study of some kind. So you will have created some new data. That data is the most important data to protect. And normally that domain type data goes into a domain repository. It's primary, and we want, of the effort that you're going to spend in preserving data, this one needs to be done really, really well. It has the most use for the future. So the second type of data that we want you to spend time on is when you are analyzing data you've created and perhaps you've combined it with something that already exists, data that already exists, and you're aggregating, you're processing it, you're synthesizing it. There's different words that different domains use. And your research results are based on this final data product. And you generate your graphics, your visualizations. We really want that to also be preserved because that demonstrates how your research, how you came about your research, your transparency. So that's the second most important set of data to protect and preserve. And then the third is the citation of existing data. So you're not responsible necessarily for putting somebody else's data into a repository, but you are responsible for citing something that you've used from someone else such that they can get credit for its value to your research. And it supports reproducibility. So those are in general, the 3 types of data that we're talking about. And they can look very different by domain. And very commonly, each paper, you have to think about this in a unique way on how it applies to each paper. So Randy, the questions that are coming into AGU's journals, does this pretty much reflect how are our authors sort of consuming this information?
Yeah, there's a lot of confusion and it varies that we receive. I think the previously existing data, number 3, we see a lot of questions related to how people should handle that, if they're able to handle that, what it would look like, what our expectations are. Also, the data, number one, data that's created, that's new, how much of the data are we looking for? How much should go into a repository? What if it's so big it won't fit into a repository? Looking for guidance around those questions in particular.
Yeah, and not all of those have easy answers right now. Many of them do. Many, especially for number one, and we'll get into this in just a moment, but there are a number of domain repositories specific for certain data types, but selecting a repository can actually be very challenging. So let's talk about that. So when you're preserving and publishing, and I hope you enjoy the humor here of the preserves there on the right-hand side, it's important that you choose the repository that can support easy discovery, as much openness and access as possible, help you as a researcher with the documentation about your data, and give you a license options that allow your data to then be shared and part of work that would happen in the future through licensing, through the different licensing options. Very commonly, the Creative Commons licensing suite is used. And then they also should help you. They also should help you with citation by giving you an example or provide you with the elements of a citation and a recommended citation format. So when you're choosing a repository, there's different ways to look at them. I'll give you this one set of examples here. This particular slide was built for a workshop that we did at fall meeting in 2019 as part of the student program. And for that one, we grouped them into 3 different types of repositories. One specifically a domain repository where you usually have someone, a data manager or your curator, that helps you with the deposit and might do some level of transformation of your data to make it align to standards that are used by the community. This is incredibly valuable for future reuse of your data. So examples of those: IRIS is seismology data. BICODEMO, that's the Biological Chemical Oceanography Data Management Office. And EarthChem, so chemistry data specific to Earth samples. And then the second category here is general or institutional repositories, which are not as likely to have support for the researcher, though some do. Some do that, but they're very good for, especially when your synthesized or aggregated or processed data isn't able to be taken by a domain repository. Some do take it. That this will most likely be where you would place that data. And there's some examples there, including Dryad and Zenodo and Figshare and Open Science Framework. And then there's also repositories that look to you as the researcher to actually do the transformation work. And those are sometimes referred to as thematic data models. And Kuwazi, who does a lot of work, captures data usually associated with hydrology. And the other examples are ones that are associated with thematic data models. So for best future understanding of your data and best interoperability, it's really the domain and thematic data model options that are best. And I say them in somewhat of reverse order, where domain helps you with the metadata and understanding. Thematic data models put you in a very standard format for interoperability and also help with understanding. So that's the reason for that. So when you're choosing the repository, what you want are these capabilities, and they'll help you with a lot of the requirements from your funders and your publishers. Using persistent identifiers for discovery, one example of that is a digital object identifier. There are others, and the repository will register that persistent identifier for you. They will also help make sure that your data can be easily discovered through using search capability. The openness and access and licensing, making sure your data is open as possible, as closed as necessary, providing you with licensing that supports openness, and then making sure that the data, the information about your data, usually called metadata, is as robust as possible. And that is incredibly helpful for understanding what the data set's all about, and considering quality and instrumentation, et cetera, standard vocabularies. So for AGU, our availability statement guidance walks you through the fact that we do need both a citation and an availability statement to be present. You want to put the availability statement in the open research section of your paper, and that you should use in-text citation and provide any access information in the availability statement, should that be necessary. For instance, some data, there is a fee to gain access. You would indicate in the availability statement that there is a fee. And it is absolutely not allowed any longer, and hasn't for some time, that data is available from the authors on request. It's just too dubious. Usually that doesn't actually work out, and authors can't remember how they put their data together or where it's located, even days and weeks after their grant is complete. Let's see. So here are some examples. So if the data is stored in a repository, you would have an in-text data citation reference along with that access information and any licensing. If the data is located in a publication, you would cite the paper of the paper itself, that literature. If it's in a technical report, like a scientific data, for instance, is a journal that does scientific papers about data sets, they will also ensure that data is in a repository. You would cite both that publication and the repository. If the data is not public available, but is available to researchers who demonstrate their credentials, then you would cite that along with the access restrictions. And then number 5 is the hardest, and Randy can give us an example of this. If data is commercially available and you've not made arrangements to share it necessarily for your publication, so it's difficult to be able to evaluate research if the data is not available, and it will be up to the editor if this would be allowed or not. Randy, do you have more to add there?
Yeah, that's one of the most challenging areas because of our journals. We have 2 or 3 where a lot of their research comes from industry, and there are a lot of non-disclosure agreements that are in place. So, really trying to ensure the authors provide as much information about the nature of their NDAs, so that anyone that wants to access the data has an understanding of what's expected and how far they can really go to evaluate the data, and then what those roadblocks would be. And then it becomes editorial discretion whether the evaluation was sufficient enough to say this research seems valid based on what we have, with the understanding that the NDA or other restrictions were in place. Another area is government policy. So, there are certain countries where, they just are really closed to sharing data, a lot of restrictions in place. So, as long as the authors are as transparent as possible, and it gives the reviewers enough information to make the proper assessments, and then provide that information to the editors, who can ultimately determine whether or not the research is sound, really communicating or understanding where those points are and where the gray areas are and what the thresholds will be for the journal has been and remains a challenge for us.
Thank you. So for your data citations, you want to include citations for all of the data used in your paper. You want to include anything that has been you've used that somebody else has created. any new data, and we've talked about that already, and then your synthesized, process, aggregated data that's used to come up with your research results. And we also mentioned earlier that any newly created data, it's incredibly important that that try to go into a domain repository. There is, and we'll have this in the resources section of these modules, the link to ESIP's Earth Science Information Partners data citation guidelines for Earth Science data, incredibly useful and provides examples. And then you should also know that the folks at DataCite have built a formatter for citations and gives you a chance to put the citation in the proper format for whichever journal that you're using, as long as you provide a digital object identifier, a DOI, and that's an incredibly helpful tool. So for modeling data, this is one of the challenging areas. Randy mentioned earlier that when data is very large and coming out of models is a perfect example, that we're really challenged in the community to store the model runs for any length of time. And certainly at the time of publication, where we're expecting that that data is part of the scientific record, there are very few repositories that can support long-term storage of large amounts of data. So what we've done is we worked with our editors to come up with an approach that would work. And what you can see here is that the most important thing for a paper that's primarily based on model simulations is that you cite the model itself. The best option is if that model's in a software repository. The second option is if it's in a general repository. Zenodo does a really great job supporting GitHub with preservation of software, for instance. And then acceptable is you may have a paper that talks about your model, and you can cite that and indicate the particular version that you used. You should have a description of your model, likely that is in your paper, and you should have provide what the configuration was, the parameters were that you ran, how you ran the model. Additionally, the aggregated, processed, synthesized, and we all have different words that we use, data that goes into the figures and the results of your paper, we do want you to preserve that and put that into a repository. And because models are somewhat complex to run, there are some community standards that are out there. Sometimes communities have a package that provides you with the scripts and the provenance and all of the data to support the paper. And an example of that is the folks that are supporting the IPCC reports have to use this package methodology. Otherwise, you want to try to cite those things yourself. What were the scripts, any descriptive detail that would rerun those models and help people understand how they were used. And put those perhaps into a general repository or appropriate repository for your community. And then the third option is trying to follow whatever your community standards are for being as transparent and traceable as possible, best effort. And then very specifically, we do not require that model data be preserved in a repository. It is optional. And the best thing you can do is contact the editor for the journal you want to publish in and see if there are any particular guidelines that are being developed for the type of science that you have that they are using. But at the moment, those are evolving, and it's best to contact the editor. One example that we can show you having to do with data citation. This is an AGU journal, Earth and Space Science, and you can take a look at it yourself too. It's an open journal. The DOI is provided there, and at the time of publication, we were still putting our availability statements within the acknowledgements section. So you can see an example here. Now it's in a section marked open research. But the text would still be the same, having to do with the data you see the data and material availability section there towards the bottom. And then you can see the 2 citations that are in the references section identified there. And hopefully that's helpful for you to get a handle on data citation and data availability statements. And that ends this particular module. Thank you, Randy. Thank you for being part of this.
Sure. Thank you, Shelley.
All right, fantastic. You guys have a great day.